Hello coders, in this video we will see next question of our LeetCode 75 list, and let's see what the question is. We have started binary binary tree DFS, and let's go to the question now. This is the next question. We have solved till this that count good, and the next question is path sum 3. So what question says? Given the root of a binary tree and an integer target sum, return the number of paths where the sum of values along the path equals target sum. Okay, we need to traverse the tree, and it should be like a path. It means DFS traversal, and the value sums, like the nodes which we visit during in that path, that sum should be equal to target sum, and then that path we can count. It means that only that the summation of the nodes that we visiting in the path is equal to the target sum, then we will count that path and we'll go ahead, and likewise we will do yeah, and that count we need to return, that is the path sum 3. It's about that only. And yeah, so we understood the question. Now what's the intuition, like what's the first thing come your mind, like when it says path, like a path sum, and we need what it says that the path does not need to start or end at the root or leaf, but it must go downwards. It must go downwards. When it says the downwards, it means it is DFS, because in DFS we just exploring, then we backtrack, then explore the other side, then explore, then we backtrack, then we explore the next thing. Likewise, we don't go the level wise, like we first in level wise what happens, we first explore the first level all, though they are connected or not, then we explore the next level, like the nodes which are connected to the first level nodes, those we visit in next level. But as they have said, the path does not need to start or end at the root leaf node, but it must go downwards. When it says downwards, and this example also, when we see that example, the intuition comes that we need to use DFS, and we need to maintain the sum of that nodes. That two things can be your mind, right? Let's write the things. The first is DFS, and the second is sum of nodes that we visit, that we visit in that path. Okay, visit in that path. And what if we traverse whole side, like here 10 5 3 3, and when we backtrack, as we are going back, we should not consider that value, right? Then we need to minus that value also. So when we visit, at that time we will add that value to the sum, and when we backtrack from that node from that node, then uh, we will subtract that value from sum. Okay, and like in first what we saw, key when we add that value, and then we check key, then we will check key is if after the adding that value, do I get the target sum, like the sum is equal to target. If yes, then we'll increase the count, and we'll see what happens in left side and right side. The same procedure we'll do in left side, the same procedure we'll do right side, and we'll get the count from the left and from the right, and we'll return the first count, that is when we have checked value that we get from the node and that we added in the sum, and then we check that how much, like is it the target sum or not, that count, and the left count and right count, that we will return. Okay, so basically it is a DFS traversal, and we need to, it is recursion, and it is like it is recursion means DFS traversal, and uh, and also 1 minute, I think recording start. 1 minute now. And also what we need to think ki, did I get that sum before or not, or if I get that sum, like what if I get more sum now, and before, as it is they have said, the part does not need to start from the root. Okay, as it is said that path can't be start from root. So did I get the sum if I start from in between? Like if I start from in between and get, like if I visit the current node from that in between node, and that sum is equal to target sum. But as I'm counting or adding the values from root, right now that value is more, then what we will do, then we will take a difference, like uh, what target sum I want and what sum right now I have, and which what the difference is, like, and we'll check if that difference was there before. Like here we'll go like, let's see at that example number 1, we are at 10, we will add 5, we will add 3. When we add 10, we want the target sum 8, and we'll check a difference that 10 minus 8, 2. Do have visited 2 before? No. Then we will add 5, 15. 15 minus 8, 15 minus 8 is 7. So do I visited 7 before? No. Then 10 plus 5 plus 3, it is 18. 18 minus 8 is equal to 10. Do I visited 10 before? Yes, I have visited. So it means that there were a point on which the sum was 10, and after that if I count, then I get the sum, like the target sum. It means I need to maintain that sum, like count of that sum, that how many times I have got that sum before. As it has said ki we have negative values also, so it may possible ki same value can be regenerated, or the same value can be said, can be, we can see that same value many times, uh, as we have negative and positive both values. So the count of that node will be, like count of that difference will be more than 1 also. So we need to store that sum, like difference means what here, the difference means what, the sum till that node, right? So we need to store that sum somewhere and count up that somewhere. So what this sentence give you intuition that sum and the count, it means the map, we can use the map in which we can store the sum and its count, and when we get the difference we will check ki do we have the difference before, like do we have the sum equal to that difference before, and if yes, then how many times we will add that, and then we'll do the same for the left side, we'll for the right side, and then we will get the actual count and we will return it. Okay, so yeah, so we did this, like we understood till this key, when we, like we understood whole, but as we are taking the notes also here right now, I'm writing it, so we'll check key till what we write it, that we wrote when we backtrack that node, then we will subtract that from sum. Okay, but before that, when we get that sum, we need to, we'll check that, we'll check difference from target node, from target sum basically, and we'll check that difference, we'll check difference from target sum, and we'll check if the difference sum, the difference means what, the sum that we got before, different sum, uh, we'll check the different sum is present in our map or not, present in our map. If yes, then we will add it, then we'll add, otherwise it's okay, otherwise we'll keep it 0, and the value which we have added now in that sum, that we need to uh, put in our map, that we need to put uh, the sum, put sum in map, or we can say we need to increase the count of that sum in our map, we need to increase count of sum in map, and when we backtrack from that node, we will subtract value of that node from sum, and then we need to decrease. I mean, what key we first increase that by one count, like by count of one, we increase that sum value, and now we will decrease the sum value, decrease the count of that value, decrease the count of that sum in map. Okay, so we wrote the algorithm. Now we need to just code it, and what let's see, and if you understood, you can code also, and in throughout the code I'll explain it again. You will understood it fully, like you will like, yeah, after the ending of this video you will say ki, yeah, I understood that video and I know this question now, I can solve this question now, or I can solve this type of questions now. Okay, let's take path sum, like let's solve this. What I said ki I want a sum which will sum the node value. So right now it's at 0. Then I want map. Let's see what's the value, what value. Okay, it can go till 10 raised to 9. So I'll take a long int, and I'll take a int that is count, and it is the map. So I'll say ki map count, sum count, and I'll return that path sum count, or you can say ki solve this question from root, and I have right now I have this sum, and I want this target sum, and I have this sum count right now. Okay, so let's solve this question. Like solve, write the solve function in control V, and yeah, this is tree node. So I'll take tree node. This is sum int, and this is target sum. As sum can be long, so I'm taking long in, and here also, and what it is target sum, and sum count is map. Okay, we'll use map here, and we'll take its address. Okay, if my root is null, then okay, if my root is null, then there is no point to count further, right? So I'll return 0. Okay, my root is null, so I don't have any path to count the sum. Then what I will do, ki I'll check the difference. That before writing this, I have the sum count. So what I can do, the sum count 0 is equals to 1 I can do, because right now I don't have any sum, and I have the sum that is 0 and its count is 1. So I did this, and now let's go ahead. That is sum. Let's take first value of that node, that is our root node. Root node's value is value, and we will add that into sum plus equals to value. And now I want difference, so I want difference is equals to sum minus the target sum, and I'll check if in sum count, I'll write it, sum count dot find the difference. If it is not equals to sum count dot end, then I need to increase the count, so I'll maintain one count variable which is 0, and I'll say ki okay, then add it into it, that sum count of that difference. And after that, what we will do ki I need to push that sum into map, that sum count. I need to increase that count, sum plus plus, and now I want the left count, which is we'll do the same for the left side, that is roots left, and we'll do right count same for roots right. Okay, and after that what we will do ki as we are backtracking from that node, what we said ki we need to reduce that sum by that value, so we will reduce that by value. And also we need to reduce that sum here. Before reducing that value, we need to reduce that sum, and then we will reduce the sum, actual sum, and then we will return the count plus left count plus right count. Okay, done. So let's run it. It is accepted. Let's run here. Okay, it's giving a wrong answer. Oh, what I can say, we can take long int here, and let's take this use case because I can see the long values. Okay, it was difference, like I needed to take long int instead of int. So yeah, it passed. And yeah, what the time complexity, let's see. The time complexity for this is, as we are visiting every node and we are storing it in map, and then we are checking it also in everywhere, like here. So the map, to check the map, it will take big of log n, and as we are visiting every node, so it's n and n log n, we can say. And then we have space complexity, which is, as we are storing those values in this map, at every sum we are storing, it is a big of n, and also plus h also, that we are, as we are solving it using DFS, that it is just internally stack data structure, and the stack data structure will use space, which is the height of the tree. Oh yeah, so that's it for guys. We can check it here also, that about the time complexity bits in here. Can I get the map? And yeah, I think it stopped giving map. Before it used to give map, but, or it gives map. Okay, I think it stopped. Runtime, and if I click here, no, it stopped giving map. Okay, so yeah, this is the time complexity, this is the space complexity, and this was the solution for this question. And we'll see in next video. Till then, bye bye.